Today we're going to learn about Section 10.1, Radical Expressions and Radical Functions. On example 1, we're asked to find the real square roots of each number. Since 5 times 5 equals 25, the square root of 25 is 5. Since 8 times 8 equals 64, the square root of 64 is 8. However, on part C, -9, since there is no real number whose square root is a -9, it does not have a real number square root. On example 2, we're asked to find the square roots of each number. The first one is a negative square root of 25/49. We know the square root of 25 is 5. And the square root of 49 is 7. So 5/7 times 5/7 equals 25 over 49. So our answer is definitely 5/7, but this negative out in front makes it a negative 5/7. The second one, we have the square root of x to the 8th, which equals x to the 4th. We can check that by taking x to the 4th and squaring it, and we get back to x to the 8th. Since we know the square root of 36 is 6, this negative out in front of the square root of 36 makes our answer a negative 6. Since the negative in front of the radical indicates the negative square root of 36. Example 3, find the cube root of 1. The cube root of 1 is 1, since 1 cubed is 1. The cube root of a -8 is a -2, since a -2 cubed is a -8. The cube root of 64/125 is 4 over 5, since 4 cubed is 64, and 5 cubed is 125. The cube root of x to the 12th equals x to the 4th. We can check it by taking x to the 4th and cubing it, and we get x to the 12th. We know from our part 2 that the cube root of a -8 is a -2. The cube root of x to the 6th is x squared. Then our answer is a -2x squared. We can check it by simply taking our answer, -2x squared, putting it in parentheses and cubing it, and we get back to our cube root of -8x to the 6th. On example 4, we're asked to simplify. And we have to be careful on this one because they're asking us to find the square root of a -3 squared. But notice that that -3 is in parentheses. When it has parentheses around it, order of operations tells us to go to the exponent first. So we know we don't have anything inside the parentheses yet to do because that's just a -3. So again, going to the exponent, it means we take a -3 times a -3 and we get 9. Now, since a -3 squared is 9, we know that the square root of 9 is simply 3. The cube root of a -4 cubed is a -4. Since the root is an odd power, we know that it can be a -4. However, I want to stop and remind you that we have a cube root and then we have a cubic function. They are opposites and they undo each other, just like adding and subtracting are opposites and division and multiplication are opposites. We have cubing and cube roots are opposites, so we go back to the original stuff inside, which is a -4. That being said, when I'm asking you to do the fifth root of the quantity 3x minus 8, to the 5th power, they just undo each other, and our answer is 3x minus 8. On example 5, we're given two functions. The f at x function equals the square root of x plus 3, and g at x equals the cube root of x minus 2. They're asking us to find each function value, so they're giving x values to us. So f at 6 means I put a 6 in the f at x function. So again, this is the x value. We're just subbing it in. So we have 6 plus 3 under the square root, which is the square root of 9, which is simply 3. Again, this is f at 13. They're giving us a value of x being 13. We go to our f at x function and just sub it in for x. So we have 13 plus 3. The square root of that is the square root of 16, which we know is simply 4. Now they're sending us to the g at x function. They want us to find g at 10. Same idea, we're just subbing in. So I sub 10 in for x in our g at x function, and we get the cube root of 10 minus 8, which reduces to the cube root of 8, which we know is 2. G at 3, again, they're giving us the value of x, and we're putting it in the g at x function. So we sub it in, and we have 3 minus 2, which we know is 1. The cubic root of 1 is simply 1.